Hello everyone, welcome to another math online lesson. Our lesson for today is solving quadratic equations by the square root property. Now we have two forms of the square root property, or the equation that can be solved using the square root property. First, in the form of x squared equals to k, where k is greater than 0, and the other one is in the form of ax plus b squared is equal to k, and still k is greater than 0. Now let's have an example, solving quadratic equations in the form of x squared equals to k. The first one is z is equal to 49. To solve this one, all we need to do is to extract the root on both sides, giving us the square root of z squared is equal to the square root of 49. Now with this, we can now eliminate the exponent 2 and the radical sign, leaving us with z is equal to 7, because the square root of 49 is 7, since 49 is a perfect square, giving us with the final answer z is equal to plus and minus 7. Next, x squared is equal to 12. Again, extract the root on both sides. This will cancel out the exponent 2 and the radical sign, leaving us with x is equal to 2 square root of 3. Now since 12 is not a perfect square, we need to find a way to factor the 12 wherein one of the factor is a perfect square. And with this, you can factor out 12 as 4 times 3, wherein 4 is a perfect square. The square root of 4 is 2, and since 3 is already a prime number, it will go back to the radical sign, giving us with the final answer as the value of x is equal to plus and minus 2 square root of 3. Now in the next example, x squared is equal to negative 169. Again, extract the root on both sides. This will cancel out the exponent and the radical sign, leaving us on this side the value of x. Now, since on this side you have a negative integer inside the radical sign, in your calculator, sometimes it will give you an I or an imaginary value, or simply null or no root. Again, if the value inside your radical sign is a negative number, there's no root. Now in our last example, you have 3x squared minus 8 is equal to 88. Now in this case, we cannot solve this one directly using the extracting the root. First, we need to separate or isolate the second term, the negative 8, on the other side. Okay, using the transpose method, transpose that one here. So you have 88, your negative becomes positive 8. 88 plus 8 is 96. Leaving us with here 3x squared. Again, we need to isolate our variable to its numerical coefficient by dividing both sides with the numerical coefficient of x squared. This will cancel out, equate to 1, leaving us with x squared here. 96 divided by 3, you have x squared is equal to 32. Extracting the root on both sides, this will eliminate the exponent 2 and the radical sign. Now since 32 is not a perfect square, we need to find a way to factor out 32 wherein one of the factor is a perfect square, leaving us with the factors of 32 would be 16 times 2, wherein 16 is a perfect square, the square root of 16 is 4, and 2 is a prime number, it will go back to the radical sign, giving us with our final answer as x is equal to plus and minus 4 square root of 2. Now let's proceed to the next one. The quantity x plus b squared is equal to k. Now in this case again, all you need to do is to extract the root on both sides. Extracting the root here and here, it will eliminate the exponent 2 and the radical sign, leaving us with p minus 4 equals the square root of 3. Take note, we have a plus and minus value when it comes to the square root. Separating the two values here, you have p minus 4 is equal to positive square root of 3, and the other one is p minus 4 equals to the negative square root of 3. Now to solve for p, all we need to do is to transpose or isolate the second term from the variable. So in this case, I'm using the additive inverse. I'll add a positive 4 on both sides of the equation, or you can just use the transpose method. Okay, using the additive inverse, negative 4 plus 4 is 0. Same goes here on the other side, leaving us with p equals to 4 plus square root of 3, and the other one is p 4 minus the square root of 3. So our final answer would be p is equal to 4 plus and minus the square root of 3. In this case, you can just directly transpose 4 here if you want the shortcut way, leaving us here p equals your negative 4 becomes positive 4, and since 3 is already a prime number, you cannot extract the root of that. The same result. Another example. You have the quantity 5m plus 1 squared is equal to 7. Again, extracting the root on both sides. This will eliminate the exponent and the radical sign, leaving us with the two values now. Since 7 is a prime number, you'll have a plus and minus the square root of 7, leaving you with 5m plus 1 on this side. Separating the two values of our quadratic equation, so you have 5m plus 1 equals to the positive square root of 7, and the other one is 5m plus 1 equals negative square root of 7. Using the additive inverse, you can eliminate the second term by adding the opposite of that one, which is negative 1, and so as on the other side. So that positive 1 minus 1 is 0. Same goes here, leaving us with 5m. You can just transfer that one here. So you have negative 1. Make sure that when you transfer a term, the sign of that term will not change, since they are on the same side of the equation. So you have negative 1 plus the square root of 7, and the other value would be negative 1 minus the square root of 7. And since we're looking for the value of m, we need to eliminate the numerical coefficient. 5 divided by 5 is 1, leaving us with m. Same goes here. Then you have the two values of your variable m as -1 plus the square root of 7 over 5, and the other one is -1 minus the square root of 7 over 5. Or you can do it here using the transpose method. You need to transpose 1 on this side, leaving us with 5m equals, your positive 1 becomes -1 plus and minus the square root of 7. And then you need to eliminate the numerical coefficient of m, divide both sides by 5. So you have your m equals to -1 plus and minus the square root of 7 over 5. The same result. Next we have the quantity 7z plus 1 squared is equal to -1. Now take note, when you isolate this one, or when you extract the root on both sides of the equation, notice what happened on this side. You have a negative number inside the square root. Therefore, in this kind of equation, there's no root. So there's no need for you to proceed in solving it. I hope you learned something today in extracting the root of the quadratic equation. See you on my next lesson.